Watching Apollo footage of astronauts doing geology on the surface of the moon is a really great way to think about preparing for Artemis, for putting people on the lunar surface once again. We learn a lot in how they did science operations on the moon and what it's like to work on the moon. You see them doing geology. You see them taking rock samples, putting in a drive tube to take a core sample. You see them bouncing along the surface of the moon on the lunar rover that they used in Apollo 15 through 17. So it's a great way to help drive technology development for the next generation of spacesuits and geology sampling tools.
There's these facilities that help us train like we are on the lunar surface. You know, these 1.6G offload systems or putting people in the aquatic environment are great ways to train the mobility part, right? Like, what can you do and how different does it feel to be in 1.6G and do these tasks?
We've been training astronauts in geology and geoscience for decades now. The Apollo astronauts had literally hundreds of hours of training in geology before they flew to the moon. It's often said that the Apollo astronauts had the equivalent of a master's degree in geology by the time they flew to the moon. In the intervening decades since Apollo, we've been training astronauts who fly to the International Space Station because when they're on the ISS, they spend time observing the Earth, looking out the window, taking pictures of what they see on the Earth's surface. Now that we're looking at putting astronauts on the surface of the moon, we also take them into the field. We take them to field sites here on Earth that resemble field sites that we expect them to see on the moon.
That's the reason why we take them out into places that are unique, like volcanic landscapes or places that are analogous to the lunar surface, to train them on the scale and fidelity of science that you just can't recreate in these facilities.
And so by combining this classroom and field training, we're able to prep them for fundamentals of geology, the major driving lunar science questions that we have that we hope to address with the Artemis program, and teaching them how to do field work in relevant analog environments.
For just science aspects of developing new spacesuits, can it get you to where you need to go? And then once you get there, can you do the cool science that you need to do? And so that's, can you move effectively and efficiently in the suit to be able to collect the samples or use the tools or the instruments? For the visibility, it's like, can you make the necessary observations that you need to? Or does the suit have the lights on it that it needs to illuminate the surface and make the observations you need to? The lunar South Pole holds tremendous resources that are going to allow us to continue to explore. This is a place that we've never been before. There's so much to be learned from getting boots on the ground and exploring a unique place that challenges us as humans and also helps us develop technologies that make our everyday life that much better.
We think there might be volatiles present at the South Pole. By using these volatiles, we'll be able to do things like create drinking water, create rocket fuel to launch astronauts back to Earth. And so by harnessing the power of the land, we'll be able to help astronauts establish that long-term sustainable presence.
It's human nature to explore. Pushing our boundaries and exploring our universe is, I think, just one of those things that's just stuck in our human nature, and that we need to do it in order to understand the world around us, including our Earth and our solar system.